Good morning, everyone. Yesterday we were, trying to graph. Good morning, Andy. We're trying to graph these functions to see the, what I'm gonna get. Well, we're gonna graph these, but we're not gonna graph them in the greatest details that we did with quadratic. Okay, so we're still gonna graph. So last time, yesterday we have you, put the points in. With the same input, and we certainly expect we will expect that it's going to be shifting up. Okay, it's going to be shifting up. So so we're going to graph all three pictures, just like quadratic. Okay, just like quadratic. So we're going to see these shifting. Okay. So let's just do it. I don't know if you guys did it after class. So 2x, 2 to the power x minus 1. Okay. If we put a minus 1 there, 2 to the power x minus 1. Okay. We're going to use the color green. Okay. If that helps. There. Oops. Right there. Hold on. I should be using red. Sorry. I should be using red. Okay. I just want to be coordinated with the other one. This should be red. Okay. Red. There's much more to it, right? Because there's a shifting from, okay, so this red is 2 to the power x minus 1. And of course, the green will be 2 to the power x plus 1. 2 to the power x plus 1. And this one is, we're going to use green. Okay. So you can see that just like quadratic, right? If you take the entire function, okay, if you take the entire function and shift up, so this is the entire function shift down, entire function shift up. And what is more, you can see the domain and range are also, domain doesn't change, but range also being changed. The range has changed as well, right? So let's mark these three in comparison, okay? So the black is certainly the black, okay? So this is 2 to the power of x, right? And the green is 2 to the power x plus 1. And the red is 2 to the power x minus 1. Okay, so it's a vertical shift. Okay, so let's see what does it imply with the vertical shift, right? The y-intercept that was here now was 2x, 2 to the power x plus 1 is shifted up by 1 unit. And I should be using green. Okay. Just try to be a little bit more color coordinated, right? So for 2x, 2 to the power x plus 1 is shifted up. For 2 to the power of x minus 1, it's shifted down by 1 unit. Okay, is that clear? Wait, Where's that green? The green has disappeared. Oh, where did that green go? The green go here, right? I could have made it thicker so that way it's easier to see. But anyway, so let's identify the y-intercepts. Okay, that's why I identified it because the y-intercept has changed, right? And 2 to the power x did not have x-intercept before. Now the red one has one. You guys see that? Okay, so there's a bunch of changes, right? There's a bunch of changes, so we should make a table to express that. Excuse me, to express those changes. Okay, so domain range and all of that stuff, right? And the shifting pattern is similar to quadratic. Okay, so now what we're gonna do is that we're gonna make a table. Okay, so clean this out. We're gonna make a table to see the changes of domain and range. Okay, domain and range. Let's see how I'm gonna put it here. Just put it on the bottom, right? Put it in the bottom. You need 3 rows. Okay, so for 2 to the power x, right? 2 to the power x, 2 to the power x plus 1, 2 to the power x minus 1. In terms of domain and range, okay, I want you guys to fill this up. Okay, in terms of domain and range, okay, domain, range, intercepts. Columns, right? Intercepts including y-intercept, x-intercept. Okay, y-intercept, x-intercept. Okay, now you're gonna help me, right? You're gonna help me. Domain, of course, we know 2 to the power x is from negative infinity to positive infinity. And the range 2 to the power x is larger than 0, right? Y-intercept, we're talking about the black, right? The black, 2 to the power x, right? And that is, what is the y-intercept? Hello? Oops. What is the y-intercept? Anybody want to answer that question?
0, 1.
0, 1, very good. That was obvious, right? That was good. I just want to check if you guys are there. Okay. So 0, 1. What is x-intercept?
None.
None. Very good. Okay. None. Now let's look at 2 to the power x plus 1. Domain stay the same, right? On the 2 to the power x, right? We have a horizontal asymptote, right? The horizontal asymptote. Now, the 2 to the power x is shifted up. So the horizontal asymptote is also shifted up along with it, isn't it? Right? There's a horizontal asymptote. The horizontal asymptote is shifted up with it. So I'm going to graph that, and you guys are going to identify the range. Could you identify the range here? Could you identify the range?
2 to the power of x is greater than 1.
Perfect. That will be 2 to the power of x plus 1 is greater than 1. Okay, not just 2 to the power x, 2 to the power x plus 1. Okay, the entire function is larger than 1. Okay, so larger than 0, larger than 1. So you can see you just add 1 on both sides of the inequalities, right? With a new function, right? Okay, okay, Y-intercept. What is the Y-intercept?
0, 2.
That's right. Excellent. 0, 2. We also saw this on the table, right? We also saw this on the table. Right here. 0, 2, right? 0, 2. All right. Next, X-intercept. Still none, right?
Yeah.
Okay. 2 to the power x minus 1. Well, obviously, domain stay the same. How about range?
2 to the power of x minus 1 is greater than -1.
Perfect. You got it. Okay, we just subtract 1 from here on both sides, right? Y-intercept. What is Y-intercept?
0, 0.
0, 0. Perfect. X-intercept.
Also 0, 0.
Yep. That's wonderful. 0, 0. You see, exponential functions, the basic exponential function doesn't have X-intercept. But if you shift it, right, you may have X-intercept. So in this case, we do have an X-intercept, right? Very good, very, very good. So what is the, I'm gonna ask you to give me the equation for the horizontal asymptote. Oh, sorry. I'm gonna put it here, insert a column. Okay, so here you wanna give me the equation of the horizontal asymptote. Horizontal asymptote. Give me the equation of horizontal asymptote. Here. Let me be there. Okay. For 2 to the power x, the horizontal asymptote was what equation? What equation is that?
Y equals 0.
Y equals 0. Excellent. Okay, that's it. And then you just shift up and down, right? So this is y equals 0. So what is horizontal asymptote for 2 to the power x plus 1?
Y equals 1.
Y equals 1. Perfect. 2 to the power x minus 1?
Y equals -1.
Y equals -1. Perfect. Okay, did you write it down? Okay, very good. Very, very good. Okay, and next we're gonna work with this guy. Okay, we know it's gonna be a kind of shifting, right? We know it's gonna be a kind of shifting. Okay, we know it's gonna be some kind of shifting, right? But these shifting we understand is different from the previous one, right? And so you're gonna shift the input, +1 and +1, right? So now, we first have 2 to the power x. Okay, 2 to the power x. I'm going to graph that 2 to the power x. And you're going to decide which one shifted to the left and which one shifted to the right. Okay, we'll start with 2 to the power x. Which one shifted to the left and which one shifted to the right? Oh, what's going on? What's going on? Oh, what did I do? Okay, 10. Wait a second. This curve looks so weird. Uh, 4. See how that goes. Okay, this is better. Okay. So this is 2 to the power x. How is this shifted? How is this shifted, right? When we deal with these other functions, 2 to the power x minus 1 and 2 to the power x plus 1. The exponents, the input, output. Hmm?
2 to the power of x minus 1 goes to the right.
Shifted to the right by how many units?
By 1 unit.
And how about 2 to the power x plus 1?
That one goes to the left by 1 unit.
Okay. Shall we confirm that? Shall we confirm that? Okay, because we're going to be answering similar questions about domain, range, intercepts, asymptotes, etc., etc. Okay, so we're going to be answering similar questions. We're going to be answering similar questions. So I want you guys to sketch on your paper. Okay, so please sketch on your paper. So I'm gonna make some adjustment to this picture. Okay, this is -1, and this is a +1. Remove, remove. All of these to be changed, right? Except the first one. Let's see, what is the date today? Today is 29th, right? Is today 29? Yes, 29. Okay. So I want you guys to sketch. This time, let me give you a table. Let me give you a table. You know what? I think I will let you create your own table. I'm going to give you a couple of seconds and a couple of minutes, and I need to step out. I'll be right back. Okay. I want you to graph. Okay. I want you to show me the shifting. The horizontal. I want you to demonstrate the shifting, just like what we did with quadratic. We know it's a shifting, right? All right, how did it go? Two to the power of x on the power minus 1. And we will see which direction it shifts. You're right. Shift it to the left. I'm sorry, shift it to the right. Let me see. Did I coordinate the color right? Yeah. Okay. And then the other one, 2 to the power of x plus 1 shifted to the left. Okay. Let me make just a little bit adjustment on the scale. Maybe make it 8, 7. Okay. So in terms of shifting, okay, in terms of shifting, this time I didn't even make the table. Okay, we didn't even make the table. You guys probably by this time it's pretty good at the table, right? You can just work out a table and demonstrate. But anyway, so you can see if you can see it's a horizontal shift, right? It used to be the same, if at the same height, right? If at the same height, it is the, what is it? It's shifted to the right or shifted to the left by, okay, so on this one, this is shifting to the, shift it to the left. And the other one, shift it to the right. This time, I want you guys to mark the curve, okay? You guys need to mark the curve for me, okay? Over here, this is 2 to the power x. Color coordinated. Come on. I want it to be color coordinated. So this is a 2 to the power x, for sure. And the red, what is the red? 2 to the power of what? X plus 1 or x minus 1?
Minus 1.
That's right. Very good. And the other one, what is this one?
2 to the power of x plus 1.
Perfect. You got it. You got it. Okay. So next, we're going to see domain range and all the other stuff, right? We're going to see domain range, all the other stuff. And I do want you to see another phenomena, though. I don't want to see another, algebraic operation, though. Okay. This one is actually equals to 2 to the power x multiply 2 to the power negative 1. So in effect, it's actually half of 2 to the power x. What do you think of that? And this one, remember the wider, narrower case, right? Yes. When we were doing quadratic, when we multiply 2 to the power 2 times x squared, it's going to be more narrow. When we divide it by 2, x squared divided by 2 is wider, right? And these two are combined in this case. So this is 2 times 2 to the power x. Okay, so this one is actually 2 cases combined. On the one hand, it is shifted. On the other hand, it is also wider. Do you see that? It's a little bit wider. Okay, so I just want to point out that specific perspective, just from algebraic perspective, so we don't have to do this wider, narrower thing in this case. Okay, and next, I wish you guys to give me the domain range intercepts. Domain range intercepts. Domain should be all the same, right? How about range?
The range is all the same too.
That's right. Perfect. Yes, very good. 2 to the power x minus 1 is also larger than 0, right? And 2 to the power x plus 1 is greater than 0. Wonderful. Okay. Intercept. Y-intercept. Okay, so I'm going to clean up a little bit. Okay, so you can tell me the Y-intercept. How do you find Y-intercept?
You plug in 0 where x is.
That's right. So what Y-intercept do we get?
0, 1/2.
Very good. Okay, so for 2 to the power x minus 1, which is shifted to the right, which is the red, and that's 0, comma, half. Excellent. How about the other one?
That one's 0, 2.
0, comma 2. Very good. Okay, x-intercept.
There are none for all of them.
Oh, it looks like there are none, right? How about horizontal asymptote?
Y equals 0.
Yep, all the same, all the same. Okay, very good job. I especially, appreciate the participation. That means you really do understand. So we probably can go a little faster here. Okay, let's move forward a little bit faster. Okay, so let's do a reflection. Let's do a reflection. That should be easy, right? That should be easy. 2 to the power x. If we put a negative sign in front of it, what happens? Just like quadratic, right? Just like quadratic, I flip over. So could I skip all of these? So in fact, we have pretty much covered all of it, but just let's look at reflecting. There are 2 reflections I wish to do. Okay, EXP2. There are 2 reflections I wish to work with you. And because I want you to see those forms. I want you to see the function. I want to see those forms. Now, one is negative of f of x. Okay, and the other one is f of negative x. Are they different or are they the same?
Different.
Absolutely, very good. Okay, f of x here is 2 to the power x. Okay, and I'm so pleased to hear what you're saying, because a lot of students would be so confused. Oh, you have a negative sign, one is inside, one is outside, doesn't make any difference. Of course, it makes a huge difference, right? So negative of f of x is negative of 2 to the power x, right? What is f of negative x? Is 2 to the power of what?
Negative x.
That's right. they're reflected on the domain and range, and they're also reflected on the picture. Okay, so we're gonna work on this summary together, and you are going to work with me. Okay, you're gonna work with me. So I'm gonna include some bit more columns, because we're also gonna combine the pictures, right? So we have 2 to the power x over here, right? We have a negative of f of x and f of negative x, right? I want you guys to do the sketch. I want you guys to do the sketch. Wait, I should put this over here. Sorry, I should put this guy over here. Okay, 3 functions. Okay, and then of course we're gonna work out the domain and range. For 2 to the power x, the domain and range is already 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Got it. Okay. So I'm just arranging this table. 3, 4. Wait. Range. Oh, this is a repeat. Sorry. Don't need that. Okay. Domain-wise, certainly there's no change. Domain-wise, there's no change, right? Domain-wise, there's no change. Did you guys sketch a picture? Did you guys sketch the picture? This picture is easy. How about this one? Well, no. What's going on? Oh. All right. This is 2 to the power x. Negative 2 to the power x is easy, right? Negative 2 to the power x is easy. It's just a reflection over the x-axis, right? It's a reflection, and we're going to use red to show that. Okay, so this is 2 to the power x. This is negative 2 to the power x. How about 2 to the power negative x? How about 2 to the power negative x?
It reflects across the y-axis.
Reflects across the y-axis. Very good comment. Very good comment. So shall we plot some point? Does everybody see that? Does everybody see that? To help you see that, okay, to help you see that, I'm going to make a table for these points. There. Okay. Two to the power x. Okay, we still start with 2 to the power x. So insert rows. Okay, so remember we had what? -2, -1, 0, 1, 2, right? 1, 2. And then we plot those points, right? We plot those other points. And what are the points we plot? We plotted, let me just borrow from this table, right? We did this table. We did these tables. We did this table. So I'm going to just borrow this from this table, okay? We did this table. And next, we're going to work on 2 to the power negative x. We're still going to choose these points. Okay, we're still going to choose these points. But what happened is, okay, so this is f of negative x. Okay, so we're still going to choose the same points, but what will happen is that 2 to the power negative. So when you plug in, when the input is negative 2, and this will turn to, okay, this is algebraic training for you, okay? You ready? So when x equals to negative 2, so this guy is, the input is a negative 2. Wait. And over here, this power is negative 2. Does everybody follow me? Okay. We just want to see better. We're, you know, yeah, we want to take our time to see for ourselves. Okay, I just want to make sure everybody get this. You only have to do this a couple times. Okay, so what would this be? This is 2 to the power of 2, right? So that is a 4. 2 to the power 2, and that's equals to 4. So that point, from negative 2, the input, the output is 4. Now, when did you get 2 to the power? When do you get the output 4 for 2 to the power x? When x is 2. You see that? So when x equals to 2, you get positive 4 with 2 to the power x. For 2 to the power negative x, when x equals to negative 2, you get 4. What does this imply? What does this imply? So 2, 4, 2, 4, that was in this picture, 2 to the 2, 4. Okay, so I'm gonna put the points right there. So you see the reflection. 2, 4. Okay, it's a black dot. It's right here, 2, 4. Now, where do we reach 4? Negative 2, 4. Right? Negative 2, 4. So negative 2, 4. Okay. Negative 2, 4. So this time I'm going to use green. Negative 2, 4 should be somewhere there. I just need to adjust the scale. Did I change the point? Hold on. I think I didn't select the point. Okay, select the point. There you go. You guys see that? So this point is flipped over. So whoever responded to that, I forgot. Could you type that? Could you type your comments on the chat? Is that Cortland or is it Bailey or Mikhail? Who made that comment? So reflecting reflecting with respect to y-axis. Who made that? I'm sorry.
That was me, Bailey.
Bailey. Okay, thank you, Bailey. Can you type that on the chat, because I want everybody to see, and we're demonstrating to everyone how that reflection is done. Thank you, Bailey. You guys see that? Okay, so this point, okay, is 2, 4. And that is on 2 to the power x. okay? And this other point is -2, 4. Do you guys see that? 2 to the power next reflects across the y-axis. Okay, do you guys see that? That's how the reflection takes place, okay? The input are opposite, but they have the same output. And this green curve, of course, is 2 to the power of y. That green curve we haven't drawn, but it passes this point, right? Right? And that is 2 to the power of what? Negative x. Do you follow me? I mean, everybody. Okay, everybody, please. So if I'm graphing the 2 to the power negative x on the picture, okay, with the green, okay, I'm going to remove these, right? Do you see that? That's how it's been reflected. That's how it's been reflected. And we can see more of such points. Does everybody follow me? Let me adjust the picture just a little bit. This will be better looking. Okay, so these are the 2 points. So I want you guys to work out a few, some points yourself, okay? So in terms of input, output. And now I want you guys to work out the pair of -1 and +1. Could you try that? Just work out all these points. How about that? Just work out all these points. You will see that it's been these, you will see the points reflecting, and we're going to plot them one by one. So x equals to -1. And this is, okay, -1. And that's going to be 2. So that input is -1, output is 2. And over here you have this, right? And for 0, no problem. Okay, -0 is 0. So this is still equals to 1. So the y-intercept doesn't change. F of 1, so now this time, right? So this is 1, x equals to 1, so this is 1, and this equals to half. Okay, so 1, half. Okay, and f of -2, well, x is 2, and this is 2, and that's a quarter. So this time it's 2, quarter. You compare these points, what do we see? That's what we saw, right? We saw that reflection. We saw that reflection. So can you graph a few more points, just to experience that? Okay, just to experience that. Okay. What I'm going to do is that I'm going to make it easier for you to do the graph. Okay, I'm going to put the picture right in the middle. How about that? Yeah, I just remove this other picture. You know, I'm going to remove some stuff. I'm going to delete that. Okay, let's not deal with that function. Okay, just do this way, right? Just do this way. This is much easier. We don't have to worry about this other stuff. Okay, so this is the f of, this is 2 to the power x, and this is 2 to the power negative x. Once you get this done, you have e to the power x, e to the power negative x, you know exactly what they are. Okay, you know exactly what they are. So the points are, so let's plot that, put the points in place, right? So we did the 2, 4, right? So let's do the 1, 2. Dot, add another one, 0, 1, add another one, -1, half, 1 more, -2, quarter. Right, we have all these dots. So what is the, this is on the black one, right? This is on the black curve, 2 to the power x. Okay, and this other one is the green. I want you guys to find the pair that reflected to each side. Okay, so I want you to find the points that on the green. Okay, so what is that point on the green curve, but on the other side? What would that be? What is that green dot?
-2, 4.
From here on the other side.
Oh, that would be 2 and then a quarter.
That's right, 2 1/4 right here. Right? You see, it's kind of tweaked. This one is here, -2 quarter, and this one is over here. Do you guys see that? Okay. How about this one? -1/2, -1/2. Where do you find the other point on the other side?
You would find it at 1 1/2.
That's right. That's right. So I want you guys to plot, to put those points by yourself. Okay. To deepen that impression. And then from that point on, you never have to remember. You know it. That's built intuition. Excuse me. That's built our intuition. Okay, that's to build our intuition, right? So you can see that correspondence from table to the graph, from table to the graph. It's pretty easy, isn't it? Is it easy or hard? Tell me.
It's pretty easy.
It's pretty easy, but once you do it, it's easy, right? And you start to see it with your mind's eyes, right? You start to see it in mind's eye, because from here, what we want to extend is we want to think, we want to say, okay, how do you visual e to the power x? Of course you can visual, but how about e to the power -x? Huh? You guys will be dealing with these functions all the time in calculus classes. Okay, you're going to be dealing with this function and that function a lot. You're not going to be dealing with much of 2 to the power e to the, 2 to the power -x, 2 to the power x. You're not going to deal with these very much. I guarantee you. But these are the functions that are simple enough, we can handle them easily, and they're similar to that. Okay? So once we do this, once we do with 2 to the power x and e to the power x, they're just similar. They're just similar in terms of domain and range. And of course, there'll be some variations, right? But they're very, very similar in many aspects. All right, so let's put those points in place. Okay, and we're gonna mark those points. Okay, I'm gonna mark those points. And we have -2, 4. So I just need to get all these other points in place. Okay. And what I'm going to do, I'm going to ask you guys to do with me is I'm going to mark all of these points and you guys are going to work with me to mark those points. Okay. All right. Two quarter. There. Okay. So are you ready to mark it with me? And this green dot is what? 2
1/4.
1/4. Which is reflected from here over there, right? And this dot, 1 comma
1/2.
1/2. Very good. Right? And you know, the y-intercept stay where it is. And this point,
-1, 2.
-1, 2. How is it reflected from here, right?
Yeah.
Reflected. And this is the reflection I think Bailey was talking about. You guys follow me? This is the reflection Bailey was talking about. So when we talk about that reflection, that's how it's being reflected. And next, last one, -2, what?
4.
4, which is reflected from here, right? Which is reflected from here. Okay, does anyone have a question? Oh, we're good. Are we good? Next, I want you guys to do E. Okay, before we do E, okay, I want you guys to do E by your own hands. Okay. Before we do E, I do want to point out another algebraic manipulation. Okay. 2 to the power of -x is actually 2 to the power of -1 to the power of x. It is also 1/2 the power of x. You see that? Right? Same thing. Same thing. Okay. So we're going to take a break for 10 minutes. And after we come back, we're going to be working with the E. Okay, do you want to take a break? Okay, let's take a break. And after we come back, we're going to do the E. Okay, so I will see you guys in 10 minutes at 9:05. Okay, at 9:05.